Supplemental math videos from Circle Christian School. Segments in a circle. Match the formula to the shape and then do the math. These are the ones that use things like the quadratic formula. Two chords in a circle. Part of the first times part of the rest of it, and part of the first times the part of the rest of it. They equal each other. They're congruent. So, using what we've been given, what I'm going to do is distribute and then combine any like terms that we have. X times x, x squared, plus 2x. Setup's key here. The neater that you are in setting these up and using your algebra skills here, the better your answer is going to be, the better you're going to understand what's happening here. So I'm going to distribute the 4 times the x, and 4 times the negative 3, watch your integers, it's a negative 12. Oh my, looky here. Again, we have something with a power of 2. Always go to the highest power to start isolating things. And I don't see where I can cancel any of those out. So I know I'm going to have to do something quadratic. It's all going to have to equal 0. So we're going to go minus the 4x and minus the 4x. And that's going to give us x squared minus 2x equals the negative 12. Okay, got to do a little bit more. It's not quite equals 0 yet. So we're going to add a 12. We're going to add a 12. And that's going to give us an x squared minus 2x plus a 12 equals 0. Alright, so that has gotten us to where we have a quadratic equation, but now we're going to have to use our quadratic formula. Okay, so let me erase this and rewrite it so I've got some more space. And so we ended up with an x squared minus a 2x plus a 12 equals a 0. Always identify your A, your B, your C. A, B, C. It's easy as 1, 2, 3. Okay, the A is 1, the B is a negative 2, and the C is a positive 12. And I'm going to make a template of my quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a all over 2a. Practice doing that, saying it as you do it, and you'll learn the formula quicker. Plug in my a's, 1, 1, 1. Plug in my b's, negative 2, inside the parentheses. Again, that keeps the integers happy. And we get a 12. This is actually going to be kind of an interesting one. Not that you can't do it. Something we revisit in Algebra 2, but in reality, if you did the chalk dust Algebra 1, you actually did get to complex numbers. All right, so we're going to finish out the first one here, which gives us negative, negative 2 over 2. And that's going to give us a 1. So we have a 1 plus minus, and now we're going to do some radical work. All right, so we have the square root, a 4 minus 48 over the 2. And this is going to give us an interesting radical of a negative 44 over the 2. Now this doesn't mean that we can't do it because we have a negative, because you'll remember that anytime you had a negative square root, like this negative square root 44, we're just going to change it into a complex number, which is going to be square root 44, and we give it that little I. I in algebra equals a square root negative 1. And we're going to have to reduce the 44 here, which gives us a 4 and 11, a 2 and a 2. So a 2's coming out. The 11 stays inside. We get the nice little I all over 2. Number to number, the 2's cancel out. So our final answer is 1 plus or minus square root of 11i, which has to stay that way because it's part real and part imaginary. All right, for the next one here, this is when we have two secants going through the circle, and you just have to remember the formula here. The external secant times the whole secant equals the external secant times the whole secant, which I've already done for you and I've already set up. And again, you'll see that we have something quadratic, so we have to have it equal 0. So I'm going to get x squared plus 5x. I minus 40 on both sides, or that is, I have to jump the 40 over the x here. It just changes its sign. Very good. Now we have our a, b, and our c. We can use our quadratic formula. A equals 1, b equals 5, and c equals our negative 40. Negative b plus or minus square root of b squared minus 4ac all over 2a all over 2a. And I'm going to plug things in now. I'm going to plug in my a's, 1, 1, 1. Plug in my b's, 5 and 5. And my negative 40. Real numbers mean real math. So I'm going to do the fraction up front, see if it needs any simplifying. In this case it does not. Going to do the radical work. We have 25 negative 4 times 1 times a negative 40 is positive 160. So that's going to give us a square root 185, and that's all over 2. And again, we're going to have to see if the radical, the square root 185, can be simplified. I know I can divide by a 5. This is where the algebra meets the geometry. Is going to give us a 3 with a 3, a 37. Oh, look at that. 2 prime numbers. So actually, we are done. Nobody can come out under the radical. And if you wanted to do it by calculator, you would take the negative 5 over the 2 and add it to whatever the value is of 185 divided by the 2. And we would do the minus negative 5 minus, I'm sorry, that's supposed to be a 2 there, minus the square root 185 over the 2. And another Nutter Butter peanut butter cookie bar that looks like an Oreo cookie. And Oreo cookies are circular, so it actually works. We are given that we have a tangent line AB to the circle is squared equals the external secant times the whole secant. And so we're just going to plug our little numbers in. A to B equals 14. I think I'm going to change that to black. There we go. Like that much better. And A to E is X. And E to F is 28. Alrighty. So we have 14 squared, that's our tangent, equals our external secant times our whole secant, x plus 28. All right, fence of equality, work some numbers out here. 14 times 14, 196. Good to know your squares, your perfect squares, up to 15 at least. Equals, going to distribute. Circle what you're distributing, arrows to follow. X squared plus the 28. All right, again, we have something quadratic, power 2. Oops, I forgot my x with my 28. Thank you for seeing that. And we have to move the 196. It has to equal 0. And minus the 196. So 0 equals our x squared plus the 28x minus the 196. Default method, quadratic formula. So that's what I'm going to set up. A equals 1, B equals 28, and C equals negative 196. Don't let the big numbers scare you. You have a calculator for big stuff. Make a template. You'll be amazed at how better your answers will become if you use a template to plug things in. Again, it cures a lot of positive, negative integer ills. It just helps organize. It brings everything back into a step-by-step. Algebra, again, is step-by-step. I'm going to plug everything in, my A's, my B's, and then my C's. Do the front part of the quadratic formula. Negative 28 over 2 gives us a negative 14. Plus or minus. Going to do the square root work. Maybe I can find some space over here. We'll try it right here. 28 times 28. Big number. Yes, I am going to have to use my calculator. 28 squared. Use that handy little squared button on your calculator so you get 784. Plus, because we have a negative and a negative, so 4 times 196 is 784. That's interesting. So we get the square root of times 2. 1568. And square root 1568 equals approximately, let's say 39.6. And there's your answer to your question, and all is great in the Oreo circle world.